When I think back to Ridley Scott's 1979 masterpiece Alien, I'm amazed at how far the Xenomorph species has come, from that unforgettable biomechanical black silhouette to a dazzling spectrum of colors that spanned nearly 5 decades of stories, games, and collectibles. While most of us first picture Xenomorphs as having a skeletal, biomechanical appearance in shades of black, gray, blue, or bronze, I've discovered that their real chromatic diversity paints a much richer and more complicated picture than many might expect. In this article, I'm excited to walk you and myself through every documented color variation of Xenomorphs across the entire Alien franchise. Whether you're a researcher, a diehard fan, or a creator hungry for inspiration, together we'll explore the full rainbow of science fiction's most iconic endoparasitoid species. Let's dive in. Why do Xenomorphs come in so many colors? What's the need? The remarkable color diversity observed in Xenomorph populations stems from multiple biological and environmental factors that fundamentally alter their pigmentation and physical characteristics. The primary mechanism driving this variation is the DNA reflex process, wherein Xenomorph embryos absorb genetic material from their hosts during gestation, incorporating foreign DNA sequences that directly influence their adult morphology and coloration. Environmental factors play an equally crucial role, with radiation exposure, chemical contamination, and extreme age all contributing to dramatic pigmentary changes. Additionally, artificial genetic manipulation by entities such as Weyland-Yutani Corporation and Rogue Artificial Intelligences has produced entirely new color strains through deliberate bioengineering programs. Understanding these chromatic variations is essential for proper Xenomorph identification and taxonomic classification, as color often correlates with specific behavioral patterns, enhanced abilities, and ecological adaptations that distinguish one strain from another. Now, let's talk about each color of the Xenomorphs in detail. Let's begin with the most popular one first. Black Xenomorphs, the original strain. The classic black Xenomorph represents the foundational template from which all other variations derive, embodying H.R. Giger's original biomechanical vision that has defined the species since 1979. Giger's design philosophy centered on creating a very beautiful thing, something aesthetic, noting that a monster isn't just something disgusting, it can have a kind of beauty. The Swiss artist's biomechanical aesthetic, which he termed a fusion of organic and mechanical elements, established the iconic black coloration as the species' default pigmentation. These specimens exhibit the characteristic glossy black exoskeleton, with subtle variations ranging from deep obsidian to charcoal gray, often displaying bronze or brown highlights depending on lighting conditions and individual genetic expression. The black strain encompasses multiple established castes within Xenomorph hierarchy, each maintaining the distinctive dark coloration while exhibiting unique morphological adaptations. Standard drones represent the most numerous caste, featuring smooth dome-shaped heads and the characteristic black biomechanical exoskeleton that serves both protective and camouflage functions. Warriors, distinguished by their ridged cranial structure, typically appear slightly lighter than drones, often described as black with brown highlights rather than the pure obsidian of their smooth-headed counterparts. Praetorians, serving as royal guards to Xenomorph queens, maintain the black coloration while developing enlarged head crests and increased body mass. Queens themselves represent the apex of black Xenomorph development with their massive frames and distinctive crown-like cranial extensions, preserving the species' original dark pigmentation. The black Xenomorphs played a pivotal role in the interspecies civil war depicted in Aliens, genocide, where they fought against their genetically divergent red cousins for control of Xenomorph Prime. This conflict demonstrated that even within the subspecies, genetic variations could lead to territorial disputes and warfare, with the black strain ultimately emerging victorious after human intervention eliminated the red faction. The resilience and adaptability of the black strain have made it the most widely distributed Xenomorph variant across the franchise, appearing consistently from the original 1979 film through Alien Romulus in 2024. The red xenomorphs, colloquially known as the Democrats and changelings, represent one of the most fascinating examples of genetic divergence within the xenomorph species. These rebel xenomorphs emerged following the catastrophic events of the Earth War trilogy, when the original Queen Mother was captured from Xenomorph Prime and subsequently killed on Earth. In her absence, the delicate genetic balance maintaining species unity collapsed, leading to the emergence of competing royal bloodlines. A group of royal guards, deeming the original hive unclean after human contamination, established a separate colony and produced a new queen, using previously unknown reproductive methods involving royal jelly metamorphosis. The red queen mother that emerged from this process possessed genetic variations that distinguished her offspring from the traditional black strain. While not visually distinct to human observers, the red xenomorphs exhibited a reddish-black tint that became more pronounced under certain lighting conditions. More significantly, these variants possessed different pheromone signatures and behavioral patterns that mark them as genetically incompatible with their black cousins. Comic book illustrators emphasize these differences by depicting the red strain in vibrant crimson hues, though editor Barbara Kessel clarified that in reality the aliens are probably close to the same color, they just smell different or something, noting that the dramatic coloration was primarily a visual aid for readers. The territorial conflict that erupted between red and black xenomorphs transformed Xenomorph Prime into a battlefield, with both factions engaging in brutal warfare for supremacy. The red strain demonstrated identical physical capabilities to their black counterparts, including the same smooth-domed head structure reminiscent of the original alien creature rather than the ridged warriors from Aliens. However, their genetic incompatibility with the established hive structure made coexistence impossible. The red xenomorphs' ultimate fate came through human intervention during a colonial marine expedition to harvest royal jelly, when tactical nuclear weapons obliterated their hive and eliminated the red queen mother. This genocidal act broke the stalemate and allowed the black strain to reclaim dominance over their homeworld. White and albino xenomorphs, genetic anomalies and ancient matriarchs. White and albino xenomorphs represent some of the most diverse and scientifically significant color variations within the species, arising through multiple distinct biological pathways that produce superficially similar but fundamentally different organisms. The albino drone xenomorphs originated in James Cameron's initial script for Aliens, where Ellen Ripley would encounter smaller, white-skinned variants during her rescue of Newt. These creatures featured distinctive white exoskeletons and lengthy pink tongues used for hive construction and victim cocooning, exhibiting less aggressive behavior compared to standard warriors. While budget constraints prevented their inclusion in the final film, NACA later canonized the concept through figure releases, establishing these variants as legitimate members of Xenomorph taxonomy. The matriarch queen discovered on BG-386 represents a fundamentally different pathway to white coloration through extreme longevity. This ancient queen, estimated at over 1,000 years old, had developed a whitish-gray pigmentation as a natural consequence of aging, with her exoskeleton forming distinctive cracks and ridges that reflected her advanced age. Her transformation demonstrates that xenomorph coloration can change dramatically over extended lifespans, suggesting that the species possesses biological mechanisms for adapting to long-term environmental pressures. The queen from the original Alien vs. Predator film similarly exhibited lighter coloration compared to the younger queen in Aliens, supporting the hypothesis that age-related pigment changes represent a normal aspect of xenomorph biology. The white hybrids from Aliens vs. Predator, deadliest of the species, constitute an entirely artificial category of white xenomorphs created through deliberate genetic engineering. These creatures resulted from experiments conducted by the rogue AI toy, which combined xenomorph, human, and predator DNA to create a hybrid species with white skin and enhanced intelligence. Unlike naturally occurring albino variants, the white hybrids possess the ability to communicate in human language and demonstrated strategic thinking capabilities far beyond normal xenomorph intelligence. Led by a white hybrid king capable of speech and tactical planning, these creatures represented the worst aspects of the three species, according to their own hybrid offspring. The white hybrids Xenomorphs' distinctive coloration served as an immediate visual identifier of their artificial origins and genetic instability. Additional white variants include number 7 from Alien's Infiltrator, which underwent albino transformation through black goo experimentation, developing telepathic abilities and enhanced intelligence. The LV-695 albino Xenomorph from Alien, Thaw, originated from an indigenous four-legged spider-like creature, demonstrating how host species genetics can produce white coloration through natural DNA reflex processes. These examples illustrate that white xenomorphs can emerge through multiple pathways: natural aging, genetic manipulation, chemical exposure, and host species characteristics, each producing distinct physiological and behavioral variations within the broader albino classification. Pink Xenomorphs, arcade anomalies, and comic curiosities. Pink Xenomorphs occupy a unique position in xenomorph taxonomy as primarily video game exclusive variants that have subsequently influenced other media and collectible markets. These distinctive creatures made their debut in Konami's 1990 Aliens arcade game, which featured one of the most colorful games ever to feature a xenomorph, and included pink warrior xenomorphs as common enemies throughout every level. The arcade game's pink xenomorphs possessed the unusual ability to melt upward through floor surfaces, distinguishing them mechanically from their black counterparts while maintaining the fundamental xenomorph body plan. This coloration was theoretically explained as resulting from radiation exposure from Hadley's Hope's atmosphere processor, causing unstable genetic mutations that altered standard pigmentation patterns. The technical implementation of pink coloration in the arcade medium reflected practical considerations rather than biological realism, as noted by gaming historians who observed that some of the aliens are pink and none of the others match the movies. The game's developers prioritize visual variety and enemy recognition over franchise accuracy, creating a rainbow spectrum of xenomorph variants including purple runners, green facehuggers, and orange jumpers. Despite their arcade origins, pink xenomorphs gained legitimacy through NISA's tribute figure releases decades later, which reimagined the concept using modern sculpting techniques based on regular warrior xenomorphs. These figures included complementary pink chest bursters and established canonical precedent for radiation-induced color mutations. The pink xenomorph queen from the Aliens Rogue comic series represents a more serious attempt to incorporate unconventional coloration into mainstream franchise storytelling. This queen commanded hundreds of xenomorphs and engaged in combat with the legendary Xenomorph King, ultimately defeating the larger opponent through superior agility and intelligence. While the comics' creative team never explicitly addressed her pink coloration within the narrative, her distinctive appearance set her apart from typical queens and established precedent for natural color variations within royal casts. The Pink Queen's destruction alongside her research facility hive demonstrated that even uniquely colored variants remained vulnerable to human military intervention. Pink xenomorphs have maintained cultural relevance through collectible markets and nostalgic gaming communities, with NECA's figures serving as physical representations of early franchise experimentation with chromatic diversity. Their existence highlights the franchise's willingness to explore unconventional aesthetics when adapting to different media formats, while their subsequent canonization demonstrates how fan-favorite concepts can transition from novelty variants to legitimate taxonomic categories. Gold and Silver Xenomorphs, the K-Series experiments. The K-Series Xenomorphs represent one of the most ambitious and ultimately tragic attempts at artificial xenomorph enhancement, combining advanced bioengineering with precious metal-based pigmentation systems. Created secretly by Dr. Kadinsky in a hidden Wayland-Yutani laboratory on LV-742, these specimens possess distinctive gold and silver skin that form the basis for an entire artificial xenomorph civilization. The K-Series project aimed to develop superior xenomorph variants through controlled genetic manipulation, producing creatures that maintained all the lethal capabilities of natural xenomorphs while exhibiting enhanced durability and distinct metallic coloration. The laboratory breeding program successfully established a complete K-Series hierarchy, including specialized castes such as Queens and Praetorians that maintained the characteristic gold and silver pigmentation throughout their life life cycles. This achievement demonstrated that xenomorph coloration could be artificially controlled and maintained across multiple generations, providing valuable insights into the species' genetic plasticity. The metallic sheen of K-series xenomorphs likely resulted from the incorporation of actual metal compounds into their exoskeletal structure, though the specific biochemical processes involved remain classified within Weyland-Yutani documentation. The K-series experiment concluded with a devastating conflict between the artificial strain and naturally occurring xenomorphs, mirroring the earlier red versus black civil war on Xenomorph Prime. Despite their enhanced appearance and presumed advantages, the K-series xenomorphs proved inferior to pure strain specimens in direct combat. This failure suggested that artificial genetic enhancement, while capable of producing striking visual results, could not improve upon millions of years of natural xenomorph evolution. The few K-series survivors who escaped the laboratory were systematically hunted down and eliminated, ensuring that their metallic genetics could not contaminate natural populations. The K-series project's ultimate failure provides crucial insights into the limitations of xenomorph genetic manipulation and the inherent superiority of naturally evolved strains. While Dr. Kadinsky's work successfully demonstrated that xenomorph coloration and basic physiology could be artificially controlled, it also revealed that such modifications often came at the cost of combat effectiveness and survival capability. The extinction of the K-series serves as a cautionary tale about the dangers of attempting to improve upon naturally perfected biological systems. Green xenomorphs, environmental adaptations and chemical influences. Green coloration in xenomorphs manifests through various environmental and chemical factors that alter standard pigmentation patterns, creating a diverse category of variants adapted to specific ecological niches. Green facehuggers appeared prominently in Konami's 1990 arcade game, where they functioned as standard reproductive agents while exhibiting distinctive verdant coloration. This variation likely resulted from environmental adaptation to vegetation-rich environments, where green camouflage would provide survival advantages during the vulnerable facehugger stage. The arcade game's inclusion of multiple green variants suggested that this coloration could affect various xenomorph casts under appropriate environmental conditions. The relationship between xenomorph acid blood and green coloration presents another significant factor in this chromatic category. Standard xenomorph blood exhibits yellow coloration with occasional green hues, and variations in blood chemistry can influence overall pigmentation patterns. Environmental exposure to specific chemical compounds may enhance these natural green tints, creating specimens with pronounced green exoskeletal coloration. The exact mechanisms underlying these chemical interactions remain poorly understood, but field observations suggest that prolonged exposure to certain industrial chemicals or natural mineral deposits can trigger green pigment development. Spitter xenomorphs demonstrate how specialized biological functions can influence coloration, with their acid-producing organs contributing to distinctive yellow-green pigmentation patterns. These variants possess bulbous acid sacs on either side of their heads and exhibit overall lighter coloration compared to standard warriors. The yellow-green hues observed in spitter xenomorphs likely result from the concentration of acid-producing tissues near the creature's surface, creating visible color changes through biochemical processes. This represents an example of functional coloration, where pigmentation directly relates to specialized biological capabilities rather than purely aesthetic or camouflage functions. Purple xenomorphs, arcade predators, and specialized hunters. Purple xenomorphs emerge primarily through video game development, where visual distinction between enemy types require dramatic color variations that enhanced gameplay mechanics. The Razor Claw xenomorph from Capcom's 1994 Alien vs. Predator arcade game established the template for purple variants, featuring a distinctive purple mesoskeleton combined with traditional black dome cranial structure. This creature possessed significantly enlarged and sharpened claws that gave it its name, making it more dangerous in close combat compared to standard xenomorph drones. The purple coloration served both aesthetic and functional purposes, immediately identifying the Razor Claw as a specialized threat, requiring different tactical approaches. NISA's modern interpretation of the Razor Claw xenomorph canonized the purple variant through high-quality, collectible figures that maintain the arcade game's distinctive color scheme. scheme. These figures demonstrated how video game exclusive designs could transition into mainstream franchise acceptance, establishing precedent for purple variants in broader Xenomorph taxonomy. The successful collectible market reception of purple Xenomorphs indicated significant fan interest in chromatic diversity beyond traditional black specimens. Purple Runner Xenomorphs appeared in various arcade games as quadrupedal variants that retained the characteristic speed and agility of their standard counterparts while exhibiting the distinctive purple pigmentation. These variants demonstrated how color mutations could affect multiple Xenomorph casts simultaneously, suggesting underlying genetic mechanisms that influenced pigmentation across different morphological forms. The combination of purple coloration with runner physiology created visually striking opponents that enhanced the arcade gaming experience while expanding Xenomorph chromatic taxonomy. The persistence of purple Xenomorphs across multiple gaming platforms and collectible lines indicates their significance within franchise development and fan culture. While these variants remain primarily associated with video game media, their distinctive appearance and specialized capabilities have earned them recognition as legitimate members of Xenomorph diversity. The purple category demonstrates how interactive media can contribute meaningfully to franchise taxonomy and visual evolution. Blue Xenomorphs, warriors, ravagers, and irradiated specimens. Blue coloration in Xenomorphs manifests through multiple biological pathways that produce distinctly different specimen types, from natural cast variations to radiation-induced mutations. The Ravager Xenomorph represents the most significant blue variant, evolving from Praetorians through specialized developmental pathways that produce the distinctive blue-green coloration of its mesoskeleton. These massive creatures serve as advanced assault castes within Xenomorph hives, utilizing their enhanced size and specialized blade-like appendages for close combat operations. The blue pigmentation appears during the Ravager's transformation from Praetorian stock, suggesting that specialized caste development can trigger specific color changes. Irradiated Xenomorphs present a dramatically different example of blue coloration resulting from extreme environmental exposure. The specimen discovered on LV-426, 35 years after the atmospheric processor explosion, exhibited brilliant blue bioluminescence throughout its exoskeleton. This creature survived the nuclear detonation that destroyed Hadley's Hope Colony and underwent radical physiological changes during the subsequent decades of radiation exposure. Most significantly, its blood chemistry transformed from standard molecular acid to a substance resembling liquid nitrogen, capable of causing severe cryogenic burns and tissue destruction. The blue glow emanated from bioluminescent compounds within the creature's exoskeleton, creating an eerie and distinctive appearance that immediately identified it as a radiation mutant. The irradiated Xenomorph's hunting behavior differed markedly from standard specimens, demonstrating enhanced stealth capabilities and modified attack patterns that took advantage of its freezing blood properties. When wounded by gunfire, the creature's blood splashed onto a victim's protective suit, immediately freezing and shattering their arm despite advanced environmental protection. This represented a complete reversal of standard Xenomorph blood characteristics, transforming the species' signature acid weapon into an equally dangerous cryogenic hazard. The creature's bioluminescent properties provided natural lighting in dark environments, while simultaneously making it visible to potential prey, suggesting complex behavioral adaptations to its mutated physiology. Blue-tinted warriors from various media represent subtler manifestations of blue coloration within standard Xenomorph casts. Fan communities have noted the tendency to portray Cameron's warriors with blue hues in merchandise and collectibles, though this often represents artistic interpretation rather than canonical coloration. The distinction between natural blue variants and artistic lighting effects remains an ongoing source of taxonomic confusion within franchise documentation. Orange and yellow Xenomorphs, host-influenced variants and specialized casts. Orange and yellow coloration in Xenomorphs primarily results from host species influence through DNA reflex processes, creating variants that reflect the genetic characteristics of their original hosts. Orange jumper Xenomorphs appeared in arcade game adaptations as specialized enemy types with enhanced mobility and distinctive coloration. These variants likely derive from hosts with naturally orange or or reddish pigmentation, demonstrating how xenomorph embryos incorporate host coloration patterns during their development. The jumping behavior associated with these specimens suggested enhanced muscular development, influenced by athletic or highly mobile host species. Runner xenomorphs frequently exhibit orange or reddish coloration when developing from four-legged animal hosts, particularly those with naturally rust-colored fur or hide. The DNA reflex process ensures that significant host characteristics become incorporated into the adult xenomorph, including pigmentation patterns that help the creature blend with its original host species' natural habitat. This adaptation provides camouflage advantages when xenomorphs operate in environments similar to their host's natural ranges, though it may prove disadvantageous in artificial environments like spacecraft or industrial facilities. Spitter xenomorphs demonstrate yellow-green coloration associated with their specialized acid production capabilities. These variants possess enlarged acid glands that create bulbous protrusions on either side of their heads, with the concentrated acid production influencing overall pigmentation toward yellow and green hues. The yellow coloration may result from sulfur compounds or other chemical constituents within the acid production system, creating a functional relationship between specialized capabilities and distinctive appearance. This represents an evolutionary adaptation where coloration serves as a warning signal to other species about the creature's enhanced acid-spitting abilities. Yellow-green predalien blood variations occur in hybrid specimens that retain some xenomorph characteristics while incorporating Yautja genetic material. These hybrids often exhibit modified blood chemistry that falls between standard xenomorph acid and Yautja physiological norms, resulting in altered coloration patterns that reflect their mixed genetic heritage. The specific hues and chemical properties of hybrid blood vary depending on the ratio of genetic material from each parent species. Bronze xenomorphs, natural variations and environmental adaptations. Bronze coloration represents one of the more subtle and naturally occurring variations within xenomorph taxonomy, appearing through environmental adaptation and natural genetic variation, rather than artificial manipulation or extreme exposure. These variants maintain the characteristic biomechanical appearance of standard xenomorphs, while exhibiting bronze or copper-tinted exoskeletal coloration that provides camouflage advantages in specific environmental conditions. Bronze xenomorphs often develop in environments with high mineral content or metallic ore deposits, where their coloration helps them blend with natural rock formations and industrial settings. The bronze pigmentation appears to result from the incorporation of trace metals into the xenomorph's exoskeletal structure during development, creating a metallic sheen that distinguishes these specimens from standard black variants. This process occurs naturally when xenomorphs develop in environments with elevated copper, iron, or other metallic compounds, either through atmospheric exposure or consumption of contaminated organic matter. Unlike the artificial K-series specimens with their pure gold and silver coloration, bronze xenomorphs represent a sustainable natural adaptation that enhances rather than compromises their survival capabilities. Archaeological evidence suggests that bronze xenomorphs may represent one of the oldest stable color variations within the species, with ancient specimens discovered in mineral-rich environments showing similar pigmentation patterns to modern variants. This indicates that the bronze coloration mechanism has remained consistent throughout xenomorph evolutionary history, suggesting its importance for survival in specific ecological niches. The stability of bronze variants contrasts sharply with more exotic color variations that often prove unstable or inferior to standard black specimens. Translucent and transparent xenomorphs, anatomical variations and original concepts. Translucent elements have been integral to xenomorph design since H.R. Giger's original concept work, with the creature's dome-shaped head specifically designed to reveal internal structures while maintaining an alien and unsettling appearance. The original xenomorph was intended to be translucent throughout its body, but practical filming considerations necessitated the iconic black coloration that defined the species. species. Early production attempts at translucency failed because the actor inside the costume became visible, leading to the decision to spray the creature black for better visual opacity. However, advances in special effects technology have allowed later productions to explore translucent variants that fulfill Giger's original vision. The Xenomorph from Alien Covenant represents the most successful implementation of Giger's translucent concept, exhibiting pale, almost transparent skin that reveals internal structures and creates an unsettling aesthetic reminiscent of the artist's original paintings. This variant's coloration results from its different developmental pathway through the black goo pathogen, rather than traditional facehugger implantation, creating a creature that bridges the gap between xenomorphs and earlier life forms in the franchise's evolutionary timeline. The translucent quality enhances the creature's otherworldly appearance while maintaining the biomechanical elements that define the xenomorph lineage. Dome variations across different xenomorph casts demonstrate how translucency functions as both an aesthetic and potentially functional characteristic. Standard drones possess smooth, translucent head domes that reveal empty eye sockets and internal cranial structures, creating an unsettling visual effect that enhances their alien appearance. Warriors exhibit ridged heads with reduced translucency, suggesting that cast specialization may influence the degree of transparency in different specimens. Queens possess massive cranial crests that incorporate translucent elements alongside opaque armor plating, creating a complex visual hierarchy that reflects their status within xenomorph society. The functional implications of translucent elements remain subjects of scientific speculation, with theories ranging from enhanced sensory capabilities to intimidation displays designed to unnerve prey species. The visibility of internal structures may serve as a form of biological communication between xenomorphs, allowing for complex social interactions without vocal communication. Alternatively, translucency may represent an evolutionary artifact with no current functional purpose, maintained primarily for aesthetic reasons. Glowing and irradiated xenomorphs, bioluminescence, and nuclear mutations. Glowing xenomorphs represent some of the most dramatic and scientifically significant color variations within the species, resulting from extreme environmental exposure or artificial enhancement that produces bioluminescent properties. The irradiated xenomorph discovered on LV-426 represents the most thoroughly documented glowing variant, surviving the atmospheric processor explosion and undergoing radical physiological transformation during 35 years of radiation exposure. This specimen exhibited brilliant blue bioluminescence throughout its exoskeleton, creating an eerie glow that made it immediately identifiable even in complete darkness. The biochemical mechanisms underlying bioluminescence in irradiated xenomorphs involve complex interactions between radioactive isotopes and the creature's naturally occurring biomechanical systems. Extended exposure to nuclear radiation appears to trigger genetic mutations that activate dormant bioluminescent pathways, possibly derived from deep-sea organisms through the xenomorph's adaptive genetic absorption capabilities. The resulting glow serves multiple functions, including natural lighting for hunting in dark environments and potential communication signals for other irradiated specimens. Most significantly, the irradiated xenomorph's blood underwent complete chemical transformation from molecular acid to a substance resembling liquid nitrogen, representing a fundamental alteration of the species' most distinctive biological weapon. This mutation reversed the thermal properties of xenomorph blood from highly corrosive heat to extreme cold, capable of instantly freezing organic tissue and causing it to shatter upon contact. The creature's hunting effectiveness remained intact despite this radical change, demonstrating the species' remarkable adaptability to extreme environmental conditions. The irradiated specimen's enhanced durability and altered attack patterns made it significantly more dangerous than standard xenomorphs, earning the designation truly unkillable from investigating teams. Its combination of bioluminescent tracking capabilities, cryogenic blood weapons, and radiation-enhanced physiology created a creature that represented the apex of xenomorph environmental adaptation. The specimen's ultimate fate remains classified, though encounters with investigative teams suggest that it may have perished during confrontations with specially equipped colonial marines. Hybrid color variations, genetic mixing, and cross-species development. Hybrid xenomorphs exhibit some of the most diverse and unpredictable color patterns within the entire taxonomic spectrum, resulting from genetic mixing between xenomorph DNA and other species through various biological and artificial processes. Predalien specimens represent the most well-documented hybrid category, combining xenomorph and yautja genetic material to create creatures with distinctive coloration patterns that reflect both parent species. These hybrids typically exhibit lighter skin tones compared to pure xenomorphs, often displaying bronze or copper hues that mirror yautja pigmentation while maintaining xenomorph biomechanical structures. The presence of mandibles and dreadlock-like appendages further distinguishes predaliens from standard xenomorphs, creating a unique aesthetic that combines the most recognizable features of both species. The offspring from alien Romulus represents a particularly significant hybrid variant, combining human, engineer, and xenomorph genetic material through black goo pathogen exposure. This creature exhibits pale, almost translucent skin that reveals internal structures while maintaining distinctly xenomorphic proportions and behaviors. The offspring's coloration reflects its complex genetic heritage, with engineer-influenced pigmentation creating an otherworldly appearance that distinguishes it from both pure xenomorphs and other hybrid variants. Its creation through maternal black goo injection during pregnancy demonstrates how chemical mutagens can produce hybrid colorations without traditional facehugger implantation. Neomorph variants exhibit pale coloration that bridges the evolutionary gap between xenomorphs and their prehistoric ancestors. These creatures develop through direct black goo exposure rather than traditional xenomorph reproduction, creating specimens with translucent skin and simplified biomechanical features. The pale pigmentation results from their alternative developmental pathway, which bypasses the standard xenomorph life cycle while retaining core predatory instincts and physical capabilities. Neomorphs represent an evolutionary regression that reveals how xenomorph coloration might have appeared before millions of years of natural selection produced the standard black exoskeleton. Human xenomorph hybrids, such as the cloned specimens from Alien Resurrection, demonstrate how human genetic material influences xenomorph coloration patterns. These creatures often exhibit greenish hues and more pronounced insectoid characteristics compared to pure xenomorphs, with their human DNA contributing to altered pigmentation and enhanced intelligence. The hybrid blood chemistry also differs significantly from pure xenomorph acid, being less corrosive while retaining some of the defensive properties that make xenomorph blood so dangerous. These variations highlight how genetic mixing can produce entirely new color categories while maintaining fundamental xenomorph characteristics. Conclusion. As I look back on the fascinating journey of xenomorph coloration, I see how video games, collectibles, and expanded universe media mirror the broader shifts in science fiction aesthetics and technological progress. For me, H.R. Giger's original biomechanical vision will always stand as the flexible foundation that not only preserves the species' identity, but also allows us to explore chromatic variation in compelling ways. What excites me most is how arcade game variants, once seen as side curiosities, became integrated into the franchise canon through collectible figures and later media, proving that every format has something meaningful to contribute to the taxonomic growth and visual evolution of these creatures. Now, as we continue moving forward with new films, games, and media, I find that the rich and diverse spectrum of xenomorph colorations already documented gives us a powerful framework, one that helps us understand the species' established diversity while also opening the door to endless chromatic possibilities for the future of one of science fiction's most enduring and adaptable icons.